Hello, 8th grade. Welcome back. Today, we are going to kind of recap real quick what we did on velocity. We're going to take it into acceleration. Acceleration and velocity are not the same thing. Let's go over your homework on velocity, and then we'll get started. So this was the work from the other day. To find the speed of an object, you need to know distance and time. Which of these formulas shows the relationship among speed, time, and distance? This should be speed is distance divided by time. One example of a vector is velocity. A vector is a quantity with size and direction. A flat horizontal line on a distance versus time graph, right there, means that the speed is 0. You would have a 0 slope if you were in math class. The slope is how you would find the speed there. Mia walks 5 kilometers north in 1 hour. Louisa walks 5 kilometers south at the same time. How do their average speed and average velocities compare? The speed is the same and the velocities are opposite. One of them is heading north, the other is heading south. Because they're in different directions, it's different velocities. Joe rides his bike to Sheetz. It is 3 kilometers from his house. It takes him 15 minutes to get there. What is his velocity? To do this, all right, so 3 kilometers in 15 minutes. So this would be 3 kilometers in 15 minutes. How many times does 15 minutes into an hour? Is 4 times. So that's actually 0.25 hours. So you basically take 3 times 4, because that's 1/4, and it will give you 12 kilometers per hour south, because it was south to Sheetz. That was probably the hardest question on there, and you had to convert minutes to hours first. All right, let's get into acceleration. Acceleration is change in velocity. It can be changing the direction of the speed, making a right turn or a left turn. It can be going in a circle, or it can be speeding up or slowing down. So if you're pedaling your bike, suddenly you pedal harder, you speed up. That's acceleration. Oh no, a rabbit runs out in front of your bike, you slam on the brakes. That's deceleration because you're slowing down, your velocity is decreasing. Acceleration is equal to the change in velocity divided by time. Acceleration is final velocity minus original velocity divided by time. Final velocity is VF, initial velocity is VI, and then you divide by time. It is almost always in meters per second, meters per second squared, which means the same thing, or in kilometers per hour, sometimes per second. But usually, those are the two most common. The other day, in my last video, we took the velocity of my son running 10 meters. He covered the 10 meters in 3.8 seconds. Or he was doing 3.8 meters per second is how fast he was going. So his initial velocity was 0 because he started at a complete stop. We're going to go ahead and say that his final velocity was 3.8 meters per second, and it took him a time of 2.6 seconds to get there. If you plug this in, the final velocity was 3.8 meters per second minus 0 meters per second, which makes the math easy, divided by 2.6 seconds. So if you guys are working at home, you will be allowed to use your calculators for this, by the way. There's a lot of math in physics. You take 3.8 divided by 2.6. His average acceleration was 1.46 meters per second, or you could do meters per second squared. Let's try another one. Let's say that it takes him 2 seconds to stop. Well, his final velocity now, if he's stopping, is 0 meters per second. The initial velocity was how fast he was traveling, which was 3.8 meters per second. And then our time was 2, if it takes him 2 seconds to come to a stop. So we plug this in. VF is 0 meters per second minus VI, which was 3.8 meters per second, divided by 2 seconds. So negative 3.8 divided by 2, his acceleration in this case is negative because he's slowing down, negative 1.9 meters per second squared. It means the same as per second per second. Let's get into the rest of the lesson. What does acceleration look like on a graph? On a graph, on a distance versus time graph, acceleration looks like a cup. The way a physics teacher once taught it to me, if you see the cup up, you have positive acceleration. You see how this is shaped up, like it's cupping up? If it is cupping down, you have negative acceleration. Cup down, slow down. Cup up, speed up. A small acceleration over a very long period of time can still give a high velocity. You know, if you have a Volkswagen Beetle had like 55 horsepower when they first came out, you could make it to 65 miles per hour. It might take you 25 seconds to get to 65 miles per hour. If you have a Porsche, you can get to 65 miles per hour in like 3 point whatever seconds. Well, why? Because the Porsche has a lot more acceleration. You can have a large acceleration in a very, very short period of time. Bullets, for example. They accelerate very, very fast out of the gun in a fraction of a second. When you see this curve on a distance versus time graph, so that's what we're talking about here. Here, in this flat area, that is no acceleration. That's constant speed. Distance over time. So on a velocity over time, this is showing you on a velocity over time that this is speeding up as the slope goes up. If this is still a velocity over time and it is now on a horizontal line, that is constant velocity. That is a 0 acceleration. And in this part right here where it is sloping down, that is negative acceleration on a velocity over time graph. They are not the same thing as a distance versus time graph. All right, let's wrap this up. I'm going to give you some statements. If it is velocity or acceleration. At home, we're going to play along. If it's velocity, it's a V. If it's acceleration, it's an A. Let's try it. So, for number 1, distance over time. Is it velocity or is it acceleration? Distance over time is velocity. Change in position in time. Is that velocity? Is that acceleration? Change in position in time. Velocity. Change in direction while moving. Change of direction while moving. Think about it. If you're changing direction, you're changing the velocity, so therefore that is acceleration. Change in speed. Speeding up or slowing down is acceleration. A bicycle is pedaled harder. You pedal your bicycle harder. Are you going to go faster or slower or what? You're going to go faster. That's acceleration. A car hits the brakes. That is deceleration, which is still a type of acceleration. You're on the highway. Mom puts on the cruise control in the car. That is constant velocity or constant speed. Velocity. It's 8 miles to Tyrone. It takes you 10 minutes to get there. Well, miles is a distance, minutes is a time. That one is velocity. If you are falling to earth, whether you're on top of a building, jumping out of a plane, falling off your back porch, you are going to accelerate towards earth at the speed of gravity. Gravity, for those of you playing along at home, sometimes you'll see this, is 9.8 meters per second squared, so it is an acceleration. It has meters per second squared. If you're using units of meters per second, it is velocity. Meters per second squared, acceleration. And if you're sitting still, we're going to count that as velocity because you have a constant 0 velocity if you're sitting still. There's a game that you guys can play at home. We are done with the actual lesson for this section. I will be back to practice velocity and acceleration problems with you. Make sure that you read 329 to 335. The review sheet on 10.3 will be coming out to you in the Google Classroom. Until then, we'll see you next time.